Hey everybody, Matt Morgan here. In this video, we're going to talk about polarity of molecules from OpenStax section 7.6. We'll talk about what molecular polarity is, factors that make a molecule either polar or nonpolar, and we'll work some examples of molecules to determine whether they are polar or not. So in the last video, we used Lewis structures to find the shape of a molecule. Once we know the shape, then we can determine whether or not a molecule is polar. So we go from Lewis structure to molecular shape to polarity. A polar molecule has a partial positive charge on one end and a partial negative charge on the other. Polarity affects many properties, including melting point, boiling point, solubility, intermolecular forces. It's very important to know if a molecule is polar or not. For a molecule to be polar, two conditions must be met. There must be a polar bond between the atoms, and the molecule must not be symmetrical. So we'll talk about each of these conditions, and then we'll work some examples. If two different atoms share electrons, then that covalent bond is polar. Write that one line down, put stars, arrows to it. This is a very important bullet. You may have seen a set of arbitrary rules that suggest a certain electronegativity difference, okay, something like that. But if in terms of polarity, two different atoms make a polar bond. The other condition is that the molecule not be symmetrical, and we'll talk about why. A polar bond between two atoms can be considered like a small vector. I'm sure you've all taken a physics course. So let's look at some examples. We'll look at the vector. We'll see when they cancel, when they don't, when the molecule is polar, and when it is not. So here's what will work. Carbon monoxide, silicon tetrachloride, and hydrogen cyanide. We will classify each of these molecules as either polar or nonpolar. The first molecule, carbon monoxide. So for all these examples, we start with the Lewis structure. A couple videos ago, we talked about how to draw Lewis structures. Make sure you use those steps and get the correct structure. There it is for carbon monoxide. Now, oxygen is more electronegative than carbon. You look at the periodic table, elements closer to fluorine are more electronegative, elements further away are less. So what that means is those shared electrons will spend more time closer to the oxygen than the carbon. So the symbol for this uneven sharing is you will see an arrow with a small cross on one end. The cross represents the plus side. The arrow points toward the partial negative side. Since nothing cancels, we have a single vector. Carbon monoxide is polar. Okay, a partial negative on the oxygen side, partial positive on the carbon side. That little squiggly is a Greek letter delta, and that means a partial charge. Not a full negative, not a full positive, but a partial charge. Let's do another example, silicon tetrachloride. Okay, its Lewis structure is there. If you need to review drawing Lewis structures, please do. Chlorine is more electronegative than silicon. We look at the periodic table, chlorine is closer to fluorine. Those shared electrons will spend more time close to the chlorine atoms. So let's draw our polarity arrows. Those four vectors cancel. They're equal magnitude pointing in directions that cancel each other out. So the overall molecule, even though it contains polar bonds, the overall molecule is nonpolar. Okay, here's a note on silicon tetrachloride's tetrahedral shape. We draw it and it looks like it's a flat square in 2 dimensions. But the molecule really exists in 3D. And this has always been one of the challenges of learning molecular geometry because computer screens and text pages are 2-dimensional, while the molecule is a 3-dimensional shape. Here's a better indication of what a tetrahedral molecule looks like. Now the point is the polarity vectors will still cancel. But just note that they're not 90 degrees apart. If you look at figure 7.16, for the tetrahedral shape, the bond angle is 109.5 degrees. Final molecule, hydrogen cyanide, or if it was dissolved in water, it would be hydrocyanic acid. Here's our Lewis structure. Nitrogen more electronegative than carbon, carbon more electronegative than hydrogen. Here's our polarity arrows. The vectors do not cancel. The overall hydrogen cyanide molecule is polar, with the nitrogen side being slightly negative. Okay, to wrap up this lesson, we defined what polarity was. We talked about factors that make a molecule polar or nonpolar. We need a polar bond and it to be not symmetrical. That's for a polar molecule. We did some examples of determining polarity, work the homework, and of course, let me know if you have any questions. There's my email. We have online office hours Tuesday and Thursday mornings, 9 to 10 a.m. And you can make an appointment if those times don't work for you.